So I'm going to give you some guidance here on the Conservation of Mass lab. This is a datasheet. You can get this from the same folder where you're watching this video from, and you'll be putting in all your data in here. Let's go back to the lab here. I've already got the lab open along with the procedure, the way we've set this up in the past as well. So what we're going to be doing is, first of all, studying the conservation of mass in a solution reaction. So we're going to take a 250 ml Erlenmeyer flask, and there he is, 250 ml Erlenmeyer flask. Put on the workbench. We're going to get a balance, and then we're going to weigh the empty flask. So you can see that's going to be the mass of the empty flask. In the past we have measured this exactly as we've seen it here, 118.000 grams. That will of course go into this place here, mass of empty 250 ml Erlenmeyer flask. It does have a 1 here next to it because we are using a separate flask, a second flask as well. And I'm going to show you how you can differentiate between those on the lab bench, even though they look the same. Okay, so going back to that, I'll take this off the bench. I will add the 45 mils of hydrochloric acid. So I have to find the 1.0 molar hydrochloric acid here. Here it is. So I put it over the flask and I put in 45 mils. And then I can go ahead and stick this on the balance, and that would be the total mass, and of course I would write that down on my data sheet as well. I'm just going to leave it over here for now, and I'm going to get a new 250 ml flask, which I'm going to put over here, and I have to weigh that as well. Now you'll notice that the mass of this is going to be the same as the mass of this. That's the first flask that we did. But what we can do in order to distinguish between them, because we are going to put some sodium hydroxide in here as well, which means that it's going to look very similar to this one here, and you don't want to mix them up. So what we can do is we can double click on it, and I can change this description here to flask 1, and even put what's in it, which is HCl, which that's really nice. It's a good way to distinguish between them. I mark this one as flask 2. And that one's going to have sodium hydroxide, or NaOH, in it. So there we go. Now when I double click on these, of course, they'll come up with those names. So I'm going to now go ahead and add my sodium hydroxide. I've got to find it first. Let's see, what's this? 6 molar hydrochloric acid, sulfuric acid, nickel chloride, silver nitrate, mixture A. Oh, there it is, 1 molar sodium hydroxide. So it's important that, see, there's another one here, it says sodium hydroxide, it's back over here. But that's solid sodium hydroxide. It doesn't say 1 molar sodium hydroxide next to it. So you've got to be very careful. Make sure that you get the right one here. See, this is it here, 1 molar sodium hydroxide. So I'm going to go ahead and put that on here. And it will be 45 mils. So now I've got the HCl in this one and the sodium hydroxide in this one. It says now to take a thermometer and place it into the Erlenmeyer flask with the hydrochloric acid. Which is which? Well, I double click on this. Oh, there it is. Flask 1 HCl. See, we labelled it, so we're not going to get them mixed up. There we go. Thermometer goes in there. And you record that initial temperature. Now, again, all of this will go into the data sheet here. See, initial temperature of 1 molar HCl. That's where you'd put that. And of course, when you're doing the measurements, you make sure that you measure to the precision that you've got here. 21.5 degrees Celsius is what you put down there, both the number and the unit. So the next thing we do is we pour all the sodium hydroxide into the flask and we watch for any evidence of reaction. And what you will notice, there will be a change on the thermometer, spoiler alert. So let's go ahead and add these in here, and we're going to pour all of it. So you will notice that we do get a change in the temperature here. And of course, if you didn't catch how high it went, you could do it again, just by repeating what we've just done here. But try and get that maximum value the first time, and you'll save yourself a bit of time down the track. So that will be an indication there has been a reaction, because we did get a temperature change going on there. So now we can remove the thermometer, which means put it back on the shelf here, and then we can weigh it again, and that'll give us the mass of the entire contents there. And again, that'll be put into your lab report too. So you're asked to clear your station, and of course by clearing your station it means putting the stuff in the waste container, putting that in the sink. If there's anything here, I don't know if it's going to... No, that one's already used, there's nothing in it, so you just stick it in the sink. So you don't need to put that in the waste container if there's nothing in it. So then we're going to do experiment 2, which means we're studying the mass of a gas formation. And we're going to take a 150 ml Erlenmeyer flask this time. I'm going to leave this on the bench because I know I'm going to need it later. We'll need it now. I'm going to record the mass of that, and of course that's going to go onto the data sheet. And then we take a 50 ml graduated cylinder and we measure out 40 ml of 1.0 molar hydrochloric acid. So again, we're making sure that we use that 1.0 molar hydrochloric acid that we used last time. And then we can double click the flask here and we can close it. So you see it's got a sealable container here. You put closed here and it will put a stopper on top of it. So we're going to weigh that. And this is going to be the mass of the flask, presumably with the stopper as well, and whatever HCl happens to be in there. So I'm going to take that off, and that's obviously going to be recorded in your data sheet as well. And then you're going to weigh out 0.25 grams of sodium carbonate. So make sure when you find the sodium carbonate, let's see where that is here. It's back over here somewhere. That's sodium carbonate there, and that's sodium bicarbonate. Those are two completely different things, so make sure you choose the right one, otherwise you might not get the right result here out of this experiment. So again, make sure you use the sodium carbonate and not the sodium bicarbonate. And then you can just follow the directions here and take the data and see what happens.